Okay, good afternoon. So today we'll be discussing about the 3D GIS capabilities, and we'll also see a few examples how 3D GIS can be used with different technologies, which is open source and freely available. And at the end, one and two case studies also will just look into that. So, what is basically a meaning of 3D GIS? But before that, we have to follow that. We have to understand what exactly is the current status of different mapping techniques. So nowadays we have large-scale 3D maps which gets generated in a form of 3D views. Like these two are the examples of that. So a few of them will be in small scale, which is called low level or LOD01. So it's nothing but a simple DEM, and on the top of that you just wrap up the images. So that's how you get the image, the terrain 3D maps, which gets generated in a form of terrain based. This is called a small scale. Then we can also have a large scale 3D maps, which is representation of different 3D models generated inside the 3D softwares, as well as few of the 3D GIS software also allows you to do that. So once you create those models, then those models can be geo-referenced, and finally we can put it on a web. So these two are the example of the modern days 3D maps, and it has a variety of applications. You might have come across 3D maps which has been used in different navigation systems like Google navigation systems and so on. So once we have this, so earlier the technology started with just a generation of 3D data sets, and later on we required to do some kind of detailed level of analysis. So generally the 3D analysis or 3D GIS is basically a set of algorithm techniques which can be used for visualizing the large scale data set which is presented in form of 3D. So generally it's being used for creating different walkthrough models. There can also be a case where large scale GIS software can also create a city like models. Then we can also create a few fly through videos, and 3D GIS is also nowadays providing you a lot of 3D query capabilities. Like we can find out the different 3D buffer analysis and other techniques which is currently available, and that can also be performed under the form of 3D GIS. So if you look the usage of different 3D GIS, then 3D GIS nowadays being used in variety of areas. It includes from geological analysis, hydrographic surveying, navigations, then utility lines or underwater supplies, marine biologies. A lot of people are also using in ecological studies, architecture, and the 3D GIS is quite widely used under the architecture modelings and archaeological studies, especially the preserving the different archaeological sites in a form of 3D documents. So those are the areas where 3D GIS is being used. 3D GIS has now also been adapted into, especially in case of 3D urban mapping and environmental monitoring as well. So 3D urban mapping is the area where 3D GIS has grown a lot. It provides a lot of capabilities in terms of doing just navigating through the different web maps, and then doing some kind of preliminary analysis, like we can place few models which can be generated as a part of architectures and visualize and see the landscape and so on. So it's like it can be used for different planning purposes. So 3D GIS has now variety of areas where we can use it. So generally, if you look into the area in which 3D GIS is being used, then what we see is that it's basically being used or initially it started with 3D visualization techniques, especially for the geospatial data sets. So what it required is a kind of geographical data, and then we provide the location of the objects on 3D terrain based on XY coordinates, and then simply the terrain gets uh, exaggerated to give you a 3D feeling. So it's like the first example which we saw earlier, where the terrain or the image wrapping was being done. So that was the first beginning of 3D visualization in computer areas. Then later on, what has happened is that people started adding or creating large scale 3D maps, and along with that they also started creating different 3D models at multiple time steps. So that led to creation of animation models. So animation models can be used, or the animations can be used just for showing the changes which might have happened in terms of land use or land covers, or any 3D models which might have change on the geographical areas. Or it also linked to the cases of generation of simulations. So for example, if anywhere the dam breach happens, so how much time is available at downstream, such kind of analysis can be carried out with the help of 3D animations. 3D GIS nowadays is being used as a part of, or it got integrated to virtual realities, since we are having nowadays a powerful computers which allows the which allows basically the not only the locations but also allows to integrate the different camera capabilities. The cameras are also coming in terms of the cameras which is now capable of generating or creating the depth maps also. So with this end level, or the end user levels devices has a capabilities which has now been exploited for different kind of virtual reality and augmented reality cases. So in the augmented reality, basically you switch on your camera and the camera gives the view of the current locations, and then based on the location certain 3D query can be carried out and we can view the objects. Those can be done. In case of virtual reality GIS, you'll simply have the different applications which will create a virtual world, and there we can do some kind of interaction. The best example of that can be an architectural drawing. So there we can play and we can place few objects here and there, and then we can do some kind of simulation or modeling as well. Then there's also a combination of extended 3DR, which is called a mixed reality. That's basically a combination of AR and 3D world both together. So let's see the few of the example of 3D analysis. So what are the first is that we can carry out the spatial query. So the way we have the 2D buffer analysis techniques, similarly we can also do some kind of creation of buffer or 3D buffer analysis. So these are just to an example where 3D spheres is being created and all the buildings and objects which falls within the sphere has been selected. So this is just an example where we can carry out 3D buffer analysis. Same, and this has a lot of application in terms of the diffusion rates and so on. Then we can also carry out the specific detail level analysis. For example, let's say if at certain places some kind of or in a residential area, if there's some kind of explosion due to gas and so on, so we would like to know what may be the extent of damages which possible. So it's in the cases where we have to do a disaster analysis, these kind of analysis can be done real time or based on the simulations directly onto the 3 data sets. Then we can also carry out few basic analysis like which is based on the 3D geometry. So these are like what's the total area of a particular building, what's the surface, what is the total height, what may be the length if I lay let's say a cable from the top of the building to bottom of the buildings and so on. So these are the important properties which are required for doing some kind of estimation for any kind of 3D or any kind of activity, especially in the urban areas. Since nowadays the urban areas are being expanded in vertical direction rather than horizontal direction. So these kind of analysis is now becoming more and more in usage. So there are a lot of different people or the different municipal corporation are also investing to create a 3 data sets. Then we can also do analysis which may have interactions with different 3D objects. So for example, this is just an example which says that if you place a camera at a height of a particular building, then you would like to know which all area will fall in the view of a camera and which are outside the shadow area. So such kind of 3D view shed analysis can be carried out. We can also carry out the same analysis in terms of objects rather than the ground coverage, so that it will only show the areas which is on the ground can be seen. So these are another 2 example of the 3D analysis or 3D GIS capabilities which is required. Then there are different applications, like you would like to know if what are the different rain shadow area determinations based on 3D buffer analysis and the corresponding interaction. So it's a kind of the view shed analysis which can be carried out on a terrain. So this is just an example which falls under the rain shadow areas and which is not under the rain shadows areas, and that can be used for ecological studies or the understanding the different dynamics of different vegetations, because the availability of water actually plays an important role in terms of determining which particular trees will be, or which portion of the hill will be will have an evergreen forest or a deciduous forest, like that. Then there is also a few applications nowadays which is coming to find out the total solar potential. So these are the basically analysis which is being carried out based on sun movement. So in this case, what happens is you decide or create a 3D models of a particular area, and then you let the source of that is the sun as a source to move around based on the movement based on the day and time. So accordingly, as the sun moves in, then we have a different shadow length which gets created that falls on different buildings. So that gives you a kind of true solar potential identifications in terms of considering the nearby building, the shadow effect also. So accordingly, the the solar potential can be carried out based on the local circumstances of different buildings. So there, the 3D analysis can help. Then 3D analysis can also be used for different kind of reconstructions and the different scenario generation. So this is just an example where you're having a particular area and at a time T1, and then what you would like to do is at later stage you would like to know what will happen after some time based on few policy decisions. So you can put on different policy decisions and look into the scenarios which will give you that how the particular city or area will grow under the current policies, and after you put on a new policies, then how does the city will look like. So that can also be created. So this is just an example where scenario 1 is there, status quo kind of scenarios. So there are a few basic constraints, like you cannot do a constructions within 50 meters of any specific landmarks, but that's the all the construction has to be below 50 meters restrictions, so you cannot have any building more than 2 floors. Similarly, you can also so these are basically a kind of policy decisions which is local. Then there may be also cases where different planning related policies can be implemented. So this is just an example where if you have a scenario where there is no change in policies, then how does the current scenario look like? And after the we do some kind of estimations based on the different land use potentials and development directions of a particular area, then we can indicate and we can find out the areas where the new construction will come in near future. So such kind of analysis helps us to look for that what are the different potential areas where the new development can come in near future. So the other example where these studies has been done, and that has shown that if the status quo is being maintained, then how does the particular area will grow. Then there might be another suggestions which gives you the idea that you may be having current conditions, and if you make few policy changes, then you can do a kind of reconstruction plan and so on. So over here also what we are doing is we are creating different 3D models, and then we are integrating with the planning or decision policies. So this gives the kind of immediate view of a particular areas under different scenarios. So that makes the different policy or decision makers just to understand how does the landscape will look like, what will be the consequences, and their overall estimations can be more accurate. So this is basically two different scenarios of the same areas, considering in a different time frame and how the planning can be done, and accordingly the choices can be made. So here also the 3D based analysis can help us to identify those areas. So now the question is how can we start the 3D GIS analysis. So first of all, that what we can do is there may be a certain 2D data sets. So it means like you may be having some existing geodetic data sets that may be in terms of local maps of a particular area. For example, you may have different building footprints, or you may be having a certain utility lines, transport lines available with you in terms of 2D maps. So what we can do is we can use that particular data sets, and then we can identify which one of these features are actually having certain attributes which can help us in creating 3D models. So generally, if you have a footprint of a building, then corresponding footprint of the building we can create a height, and that height can be added to existing shape files, and then we can create a 3D models. So generation of the height can be done multiple ways. One is that we can do a direct manual survey if your study area is quite small. Otherwise, there are nowadays we are having a lidar based technique which gives you large scale mapping, and as well as photogrammetry and close range techniques are also available, so using which we can extract the height. So you have a the building footprint, you are having a height available to you. Combination of these is going to give you a 3D GIS base layer. That base layer then we can put it on the top of different terrain level informations. For example, that may come from DSM, or it may be a part of some contour which may be available. So there also that can be used. So combination of these two can give us a kind of base layer 3D maps, which also called a grayscale map or 3D maps, and then we can carry out different kind of analysis and visualization on these data. So this is just an example of simple 3D GIS workflow which tries to integrate the existing data sets with the other geospatial data set which is available to us, and then we can generate the models like this. There are nowadays the large scale procedure based city modeling techniques are also coming. So there are few options which is available in the area of open source and as well as closed source, which allows you to create certain rules and the corresponding attribute and geometrical informations. Based on that, you can immediately create a large scale 3D models. So these 3D models can be used again in multiple ways. Some of the 3D models is being used as a part of the gaming engine. So once these models gets generated, then that can be exported in a form of different 3D engine or different gaming engine environment like Unity and so, and it can be used. There are also other applications, like if somebody wants to do a large-scale 3D simulations based on flood mapping or disaster scenarios generations, and then we would like to see the impact and so on. So in those cases also, the large-scale data sets can be created with these techniques, and then we can generate the 3D maps, which can be used for doing some kind of analysis, post-generation analysis. So what kind of post dataset generation analysis is there? So this is just an example of a dam breach which is going to happen at a particular height. Then with the help of fluid dynamics and corresponding simulations, we can generate that what may be the impact at the downstream. So these kind of simulations we can do it. So this is basically a small scale simulations which we can do it once you have a 3 data set. So for carrying out such kind of analysis, you need additional capabilities in your 3D environment softwares, which call a physics based components, so that allows the material to flow, or the fluid, in this case the water is being considered to be a kind of fluid, so accordingly it flows in a channel. Same way we can have a rigid body motions, we can also have a free particle based animation and diffusion processes. So those models in terms of the physics based models are being available separately as a part of different physics engine of different softwares, and that using that we can integrate and we can create 3D simulations like this. So this basically gives the a kind of animation based spatio-temporal analysis of a particular areas, and that can be used for multiple applications like disaster preparedness and so on. We can also carry out the large-scale simulations. This is just an example of tsunami simulations which can be carried out. So we can have a 3D buildings which gets created, and once we have such a 3D, basically the 3D models or city models available to us, then we can look into the detailed analysis and studies. Like in this case, it's just showing that which all the buildings which is completely submerged if a particular height of tsunami is coming in area, so and which are the buildings which is the area which is the portion of the different buildings which are not affected by the tsunami waves. So these studies may help us to identify, mark special places in such scenarios, so that people life can be saved. So this is a slightly large scale or city level simulations. That was actually a kind of district, the earlier one is small scale. This is a slightly large scale, and there are also a very large scales which simulations can be carried out. So in a particular channel of areas, or maybe in a building, inside a building and so on, how does the flooding simulation, flooding situation might be there. These kind of analysis which we can do it. Then what is the uses of different virtual reality based techniques which we can use it? So first we need to understand what exactly is the virtual reality is. What is exactly the virtual reality? So generally, if any simulations or any kind of analysis which is being carried out in virtual world, so we need to have different virtual environment that has to be created, built it. So it means like we'll be having all the objects available in the virtual environment will be created artificially. So you may be having a 3D models, a road or anything else which you see. There will not be any camera-like interactions, but user will be directly interacting with the different objects in a virtual world. So that is a kind of a bounded world which gets created. Most you can think of that. This is just an there might be cases in different gaming environment, where you're at the beginning of the start of the game, you get an world which is completely virtual. There is no way of putting and going inside that world. So that particular environment, we can call it a virtual world. So to interact with that and to view that, we can use different in human computer interfaces. So that includes like headset mounted head display, or Oculus, which generally being used for seeing the 3D scenes using a mobile phones and so on. So in this case, basically, as the people moves on, the movement and the objects which is available in 3D worlds also moves in. So it means like it is not dependent upon your mouse or other interactions, but rather than the movement of your actual person who is wearing that head-mounted gears, they can use it. So these are the few examples of that. So you can mount a gear. You can also have Google Cardboard. There's also a lot of other applications are also available. Other devices are also available which can be used as a part of AR technologies. So the sophistication in terms of usage goes is that as the cost goes up, the corresponding detail level of different motion capability detections is being provided by a particular device, and which can be exploited to explore the basically in the environment. So like on the top two is basically based on visual interaction. So means you'll be only able to view the different objects, and for interactions you have to do some kind of input devices, maybe a mouse or some other maybe Bluetooth keyboard and so on to do an interactions. But there are also other devices like HoloLens and other VR devices are also available, where we can do interactions directly in front of the those devices. So means user can directly interact with those objects, and their effect like scaling, reduction, scaling, increasing, and translation on all those motions immediately gets transferred through the same device where the actual 3D world is being projected. So this gives the immediate interactions. So that enables or provides an additional capabilities in terms of interactions. The hologram are also the uses, few of the uses which we might have seen earlier. So this is just an example where the web-based VR AR technologies can be used. So you have a open web VR technologies. So what it does, it takes the location of a particular area, and if you're having a 3D maps available for that particular area, then different symbols or the navigation scenarios can be generated and can be shown in. So in this case, there's a two important component which should be present in your device. Like you should have locations from which, and then you also need to provide a camera so that you can link the different objects to the AR world. So the difference between VR and AR is that you will be seeing the different or the virtual objects added additions to what you can see on the camera. So different trees are actually natural one, but these markers and other things gets created based on locations and corresponding informations team. So this has a variety of applications where user can directly interact. Just point your camera in a particular orientations and you'll come to know the detailed path. So this becomes a kind of important tool, especially if somebody is or some places if you're having walk paths. So walk paths may not be observed and seen on the on a satellite maps or satellite photo of images, but these walk paths can be created temporarily, and based on that the interaction of the users can be done and we can get it. In the there are also an A-frame technique. So combination of web VR gives you the access to a particular area, where A-frame techniques allows you to create VR head-based VR technologies. It's basically generation of the stereo projection of a particular scene on devices like on Oculus, and that can be used for seeing those stereo images, and then the user can do some kind of interaction in terms of visualizing another aspect. So these are basically an AR technologies which is currently available. So there are a lot of different applications. So these are just an example where you can create a 3D photosphere. So that allows that based on your image orientations, you can have a 360-degree image cameras. Like in this case, we are seeing the image of a clock tower in Dehradun and the corresponding surrounding areas at a particular place. You can create that. You can also create a few specific image related markers. So it means like it's an integration of AI and corresponding AR and VR techniques. So what happens is that when you point your camera directly on the to a specific marker in terms of the way you are having a QR codes, similarly different markers might be created, or you may have some marker which is image based. So you can create these two marker as a part of AI image processing. And once you see that, then using specific applications like camera applications which is capable of reading QR, or the other applications which can be provided by the application user itself. So just point your camera to a particular image marker or QR markers. The corresponding features or 3D augmented or 3D virtual objects will get created, and then we can do a lot of different interactions. So as soon as the object comes, you can provide some kind of descriptions. You can also aid additional audio-visual capabilities. So that gives the feeling of on the at the place feeling to the end users, and that can be used in variety of different applications. We can create an virtual tour guides and so on. So those kind of things can be created. We can also create a kind of markers which will be in terms of navigation. So you no longer will have 2D maps, but rather than 3D maps giving you detail of different locations and navigations, corresponding billboard representations on during the interactions, and that can be used for variety of applications. So where VR and GIS applications gets integrated. So that's what those are basically the things which you have seen was a part of your desktop based or mobile application based systems, but we are also having the uses in terms of complete 3D GIS platform which is available to us. Like CGM JS is just one of the example of that. So the basic CGM JS library or the JavaScript library which is available to us, it provides you the different 3D capabilities in terms of, or GIS capabilities, 3D GIS capabilities in terms of loading or reading the different data layers onto the sphere, on a earth sphere. It also allows you to carry out few transformations, do some kind of animation and interactions and so on, so that we can do it on the fly. We don't need to have any specific software, just open a web browser, and this can be made in responsive. So it means like it can make the shapes can be changed based on the device's capabilities. So the corresponding globes gets created, and on this globe then we can do a lot of different interactions. For example, such virtual 3D 3D models has been used for creating a base layer 3D models which can be used for landscape visualizations, that can also be connected to do or carry out the flood simulations in terms of city disaster modeling and so on. We can also do a query or do some kind of analysis in terms of change detections. So like at different 2 time period which our building has changed depending upon the availability of 3 data sets, we can do such a kind of query. We can also do a detailed level of economical modeling based on the land use. We can do, and we can check that what is the total area and corresponding expected revenue from those areas, that can also be carried out. So those kind of economical modeling can be carried out. And there can also be a detailed scale, a detailed level of energy efficiency computations and solar potential just on the basis of rooftop. You can do that. So there are a few web applications are also available, which is built on the top of CGM JS. We can also do different kind of animations query in this, or any different kind of interactions. So those includes a simply attribute based query. So you can just select an objects and corresponding attributes can be displayed, or we can also do a large scale classifications of the data set based on 3D attribute based on the 3D object attribute information. So that gives you a kind of spatial distributions which can be used for doing multiple analysis, in starting from socioeconomic status, the nature of city identifications, and so on. So those kind of things which we can carry it out. We can also a specific attribute filtering just to see the segregation of different classes of 3D objects, and we can also carry or do some kind of basic animations, like their large scale animations. So this is just an example where you may be having a GPS track available to you, and you can use it for generating the different scenario, like at what speed particular object was moving while capturing the lines and so on. So those kind of animations and other activities, all these capabilities are existing in CZM.js, and we can use it for doing all these activities on the CZM.js globe. Then this is just an example of, apart from the interactive visualizations, how we can carry it out. So you can have 3 data sets which may be available in a standard formats like CTGML and so on. So you can directly read it and overlay on the top of the 3D terrain which is provided by the CZM globe. And then you can do analysis like buffer analysis or the axis alignment, bonding box based, what are the building which is falling in. So it allows you to create also the custom based your own applications and libraries which can be used for carrying out detailed 3D layer analysis directly on a web interface itself. So user did not have to install any specific software. With the current HTML5 technology based browsers, these analysis can be carried out. So the other few examples, like you're having a photograph which is actually image AI marked, and what you can do is you just point your camera, open the applications, and as soon as your view of the object is available within a camera, it gets displayed. The virtual object gets displayed. As soon as that object goes off the current view, the object disappears. So it's a kind of an example where image based AI marker techniques is combined with augmented reality capabilities just by opening your camera, and you can create simulation and models which can be used for a variety of applications. Similarly, what we can do is we can create 3D markers like this, and once this 3D markers opens, then what happens is as soon as you point it at a particular locations, the 3D objects gets added to it and you can use it. So it's just a simple applications which is available again as a part of on a GitHub libraries. You can play with that, and that can be extended to create a large scale applications which we have seen a few of those examples which we have seen it earlier. So with this I'll be closing today for the current sessions, and then we'll come back for a few questions.